About 13.75 billion years ago, in a snapshot of time that challenges our understanding, the universe as we know it today began. A cosmic explosion unlike any other, the so-called Big Bang, gave birth to everything we see and know: stars, planets, galaxies, and every other form of matter and energy. In that earliest phase, the universe was an infinitesimal singularity, extremely dense and hot. Shortly after, primordial light began to radiate through the cosmos, spreading in all directions and marking the universe's first moments. This event marked the beginning of the cosmic microwave background, a persistent echo of the explosion that we can still observe today as a faint but fundamental trace in the sky. In the first instant after the Big Bang, the universe underwent a rapid expansion, a process known as cosmic inflation, which lasted only fractions of a second. Yet this expansion was so fast that it determined the fundamental structure of the universe that we can observe today. Incredibly, the forces we now know as gravity, electromagnetism, and the strong and weak nuclear forces were indistinguishable, unified into a single fundamental force. Over time, however, these forces began to separate, giving rise to the physical reality we see around us. As millennia and billions of years passed, the universe continued expanding, though initially at a slower pace. However, against all expectations, the universe began accelerating its expansion due to a mysterious force scientists call dark energy. The discovery of this energy, made in the early 21st century, upended our conceptions of how the universe evolves over time. This force seems to permeate all of space, pushing galaxies farther away from us and driving an expansion rate that could lead to an end no one can predict with certainty. Over billions of years, the cosmos has continued to evolve, revealing ever greater complexity, from the formation of galaxies to the birth of stars, from orbiting planets to mysterious subatomic particles. Every day, physicists and mathematicians strive to uncover the secrets of this vast and enigmatic universe, seeking answers to questions that go far beyond our immediate perception. Every discovery seems to raise new mysteries, as if the cosmos hides an infinity of secrets yet to be revealed. Some scientists venture beyond the boundaries of the observable universe, imagining what might lie beyond. Are there truly other universes, unknown worlds, or unimaginable structures? If so, what do they look like? What might we find if we could go beyond the limits of what we can observe? These are questions that challenge our ability to comprehend, and the answers could be even more surprising than we can imagine. To understand what might exist outside the observable universe, we must first define what we mean by the universe itself. The concept of the observable universe refers to the portion of the universe we can directly observe, limited by the finite speed of light. Since light takes time to travel, what we can observe is only what lies within a certain distance, the distance light has been able to travel since the universe began. Scientists estimate that the observable universe has a diameter of about 93 billion light-years, a number that defies any human conception of scale. This vast space contains everything we know: stars, planets, quarks, black holes, and even objects we have not yet had the chance to observe. Yet what we see is only a fraction of the whole, a small fragment of a possible infinity. The observable universe may be finite, but the entire universe might be infinite, extending far beyond our visible horizon. Beyond the boundary of the observable universe, there could be other galaxies, other planets, and perhaps even alternate versions of ourselves in scenarios we cannot even conceive. One particularly fascinating phenomenon that has captured astronomers' attention is the so-called dark flow, discovered in 2008. At that time, astronomers noticed that enormous galaxy clusters seemed to be moving coherently, all heading toward the same point at extraordinary speeds, over 3 million kilometers per hour. This motion was confirmed in 2010 and, according to some theories, might be caused by massive structures outside our observable universe exerting a gravitational pull on us. These structures could be accumulations of matter and energy so vast that they escape our ability to detect, or they could suggest the existence of other universes connected to ours in ways we do not yet understand. Other theories claim that the universe itself could consist of a network of spatial bubbles, each with its own physical laws. In this view, our universe would be just one bubble among many, each separate and independent but expanding within the same infinite space. However, the distance between these bubbles might be so immense that any interaction or communication between them would be impossible. Another proposal, from Lee Smolin, suggests that black holes might serve as seeds for the birth of new universes. According to this theory, every black hole could be the gateway to a new universe, where physical laws might differ subtly but fundamentally from ours. This idea, resembling a kind of cosmic natural selection, imagines that universes generating more black holes are destined to proliferate, while those that do not will disappear. Though intriguing, this theory has been largely abandoned by Smolin himself and other scientists. String theory introduces an even more radical vision with the concept of branes, structures extending through additional dimensions and which, according to some models, could interact with one another. When two branes collide, they could give rise to new universes. In this view, the gravity we experience might originate from another universe, explaining its mysterious weakness compared to the other fundamental forces. Parallel universes, then, could exist in additional dimensions, detached from ours but somehow interconnected. The questions arising from these theories are both fascinating and unsettling. Do other worlds exist beyond our universe? If so, what are they like? Is infinity truly as vast and incomprehensible as we imagine? Parallel universes, spacetime distortions, black holes, and string theories. Are these mere fantasies, or could they hide scientific truths we have yet to understand? Science is slowly unraveling the mysteries of the cosmos, but the journey is long, and the answers may surprise us in ways we cannot yet predict. Or perhaps some secrets will remain eternally out of our reach. What do you think? Share your opinion in the comments, subscribe to the channel, and activate the notification bell to not miss the next videos.